Hi everyone. In today's installment of Programming for Lovers, we will introduce a map, a data structure that consists of a collection of keys with one value associated to each key. We will see how Go implements maps so that we will be ready to apply maps to analyze genomes. If you enjoy what you see, please like, subscribe, and join our course at programmingforlovers.com. Let's code. To get started, you'll notice that I've created a folder called Maps within our Go src source code directory, and then I've got a file named main.go in there, which is what I'm going to edit. Now we're going to be talking about maps, and maps are variables like any other variable, like an integer, like a slice or an array or a string. And so accordingly, when we're thinking about declaring a map, I can declare a map with a var keyword, followed by the name of the map. And the map that I want to declare is going to be called polls, and then followed by the type. And I want to tell you what polls is. This is going to be a pointer to something that we're going to work on in a later chapter of the course. Polls is going to be a variable that takes as keys strings, which are state names, and it's going to map each of those state names to a value, which is the polling percentage for a presidential candidate in that state in the United States. And so if we're mapping state names as strings to polling percentages, we need to have a map whose keys are strings and whose values associated with those strings are float 64s to represent decimals. And now the next thing I would say is, all right, well, Go is strict about these types. So it wants every key to have the same type and every value to have the same type. And it's also strict that if we want to start adding things to this map called polls, then we need to make the map in the same way that we would make a slice. So let's do that. I'm going to set polls equal to make a map of strings to float 64s. And in practice, if you're wondering, we will always use polls, probably, equal to make map string float 64. In other words, just like slices and arrays, there's going to be a one-line declaration for what we want to do. I'm showing you the two-line declaration here just so you have it. And then the next question you might have is, well, you made the map, but you didn't tell it how long the map needs to be. And this is a key point, that unlike slices, we don't need to specify the length of the map in advance. We just need to create the map, and then as soon as the map is made, we can start adding values to it. So I could set some values here. For example, let's set the polling value for this candidate in the state of Pennsylvania, where this is being recorded, equal to 0.517. And let's set a couple other values too. So we might set polls of this candidate in Ohio is equal to 0.488. And polls of the candidate in Texas is equal to 0.378. And we're going to add one more. Let's add Florida. And they can never make up their mind on who they want to be president, so let's let them have a polling percentage of 50%. And so we can set each of these key value pairs with formulas like this in general. The next thing I would point out is, now that we have set a few values, we're going to be able to determine how many keys and value pairs are in this map by using a built-in function called len, which is the same thing that we've used for arrays and slices. So, for example, if I wanted to say the number of states in the map is, I could print out length of polls, and that will print out 4. So let's compile and run this. I can go into my terminal and pull that up. And you'll see that it's going to automatically go to my Go directory. So I can cd or navigate into src maps and then compile that and run it with either maps.exe on Windows or since this is a Mac, it's not a map, it's a Mac, I can use /maps. And so I see the number of states in the map is equal to 4. Now, let's get rid of Florida. Let's just do the whole world a favor here. And if I want to remove an element from this map, I can use another built-in function in Go called delete. So getting rid of Florida. Okay. Delete. We need to give delete the name of the map and the name of the key that we want to get rid of, and that will get rid of the key value pair. So I'll do that, and I'm going to call this print statement again, and you'll see that after I delete Florida, we're going to have the number of the states in the map goes down from 4 to 3. So working with maps in this way is I think, pretty straightforward. And the next thing I would point out to you is this is not a very large map. Sometimes that's going to be the case. Sometimes you're just going to have a few values that you want to set in a map. And I'm going to use this as an opportunity to talk about that exact same case briefly with respect to arrays and slices too. So if you, for example, knew that you wanted to have a DNA alphabet slice, or let's say make an array of length 4, and it's going to contain just 4 symbols. So the symbol type here is byte. I could make an array of length 4 just with colon equal the length of the array, which has to be a constant, the type, and then curly braces, and then the 4 things that I'm putting in there, which are going to be the symbols A, C, G, and T. And then let's do another example. I'll show you for say a slice. Say that we had primes and we don't know how many primes we're going to put in there, but we're going to put the first 5 prime numbers. So here I'm going to still have brackets, except that I'm not going to specify a number there. I'm just going to have the slice of integers, and then I'm going to give it 2, 3, 5, 7, 11. So that's going to allow me to have a slice, which means if I want to change the length of that thing later, I'm going to be more than welcome to do so. These are called array and slice literals. And I'm going to comment them out just because I'm not using these elsewhere in this code along. So I'm going to use a multi-line comment and comment that stuff out. But I am going to use that as an opportunity to talk about map literals, because there are map literals too. So let's declare a map literal. And in practice, a key point about the US presidential election is that, yes, there is a polling percentage associated with each state, but another critical piece of data is the number of electoral votes that that state receives, because the presidential election is based off of an electoral college where each state gets 2 electors and then a certain extra number based on their population. And so we could create, for these 3 states that we have, say an electoral votes map that's going to associate each state with its number of electors. And we could do that with, let's call it electoral votes. I'm still going to have colon equal to something. And here I'm going to have a map of strings to uints, since the number of electors is never going to be negative. Let's use our unsigned integer type. And now I'm going to have my braces, but there's going to be quite a bit here. So I'm going to put each key value pair on its own line. And let's do that. So I'm going to say, we're going to take the 2020 values. And in 2020, Pennsylvania had 20 electors. Ohio had 18 electors. And Texas had 38. And I will save that. And I will say one more thing, which is that this looks very natural, but you'll see that I've got a little red squiggly mark here because I have the Go extension installed. You might wonder, why would there be something angry about the number 38? And the reason why is because Go demands that we put a comma at the end of every single line, including the last one. Go demands this final comma for consistency. And you might wonder, why is that? I think it's for good reason. It's in case we wanted to go in and add a new line to this map literal, and then we forgot that we needed to add that extra comma. So just for the sake of consistency, the compiler is going to make sure that we see a comma on every single line of that map literal. I want to do something with this map literal that we created. So the thing that I would like to do is to point out that technically, between 2020 and 2024, the number of electoral votes for each of these states changed. And so I'm going to have an update votes function that's going to take in a map of strings to uints. And it's not going to return anything. It's just going to update the values in this map. So it turns out that as you might expect, voters are fleeing our cold Rust Belt states of Pennsylvania and Ohio. And as a result, we've lost an elector from each of those states. So they've gone down to 19 and 17 respectively. And lo and behold, Texas, which has all the sunshine and low taxes, like 12 guns for every man, human, woman, and child, it's gone up by 2. So it's gone up to 40. Yay, Texas. And so there's our function. It's just going to update these electoral votes. And I want to use this function to ask you a question, which is, say I go in and I want to print out the number of electoral votes associated with one of these states. So say I want to print out, at this point in time, the number of electoral votes in Pennsylvania is now, and I want to give it electoral votes of Pennsylvania. And this is an easy answer to this question because I didn't call the function. So if I were to run this now, then you'll see 20 is going to get printed. In fact, I'll do so. I'm going to compile, except that I have a compiler issue. I forgot to use the func keyword down there. I'm going to compile and run, and the number of electoral votes is 20. Nothing surprising there. But let me instead, before calling that print statement, let me call update votes of my electoral votes map. And here is where I would like to ask you to just stop for a moment and think about what you think is going to get printed. I'll give you a hint that there's only 2 possibilities. We could print 20, or we could print the value of 19. And there's a compelling case to be made for each of those. Possibly, when we call update votes of electoral votes, a copy of this map that we created in funcmain gets produced, and if a copy is produced, then that copy will have scope only within the function. So we'll be updating the copy that we created to have electoral votes of Pennsylvania equal 19, and then when the function's end is reached, we're going to delete that copy. So we would be getting rid of that copied map. That's possibility 1. Possibility 2 would be somehow when we pass in the electoral votes map into the function, then we get access to the map that's behind the scenes. We're not truly creating a copy. And so that in that particular case, we would see that the number of electoral votes in Pennsylvania is now 19. So there's 2 possibilities, 20 or 19. I'll let you pause for a moment if you would like and think about that. There's no real wrong answer. Well, there's a wrong answer. There's definitely a wrong answer, but there's no wrong intuition. And so I'll let you pause if you like. In the meantime, I'm going to show you. So when I save this, and then I compile it, and then I run it, we see that it actually is 19. And that's different from many things that we've worked with. If you have a basic built-in type like a string or integer, something like this, and you pass it into a function, we always know that we're passing that in by value. We're creating a copy of any of those variables, and that copy of the variable is what's going into that function, and the copy may get edited, but then it gets destroyed. In this particular case with a map, maps are passed by reference, which means that when you pass in a map to a function, you're getting access to that map that you passed in. And so when you change it, you're changing it globally. You're changing it out here as well, which is what we saw in funcmain. So we pass electoral votes into the function, a copy is not created, that electoral votes map gets edited, and so we can see that things actually changed globally. An important thing to know. Let's range over all of the states. So let me use this as an opportunity to talk a little bit about ranging with maps in Go. And ranging is going to behave similarly to how it has behaved for arrays or slices. We're still going to have a range keyword. And so if I want to range over both the keys and the values, the notation that we're going to have is going to be very similar to ranging over the indices and the values of, say, a slice. So if, for example, I wanted to range over the state and the number of votes in my electoral votes map, and then I wanted to print the number of votes in each state, I could say the number of votes in, and with this type of ranging, I'm going to be ranging over the keys and the values. I don't have to use this. I could instead have just state colon equal to range over electoral votes, and then I would just be ranging over the keys. And in that particular case, I could say the number of electoral votes in, comma, state, and then is electoral votes of state. But I also have this shorthand where I'm going to be able to range over the values too, and I'll have a comma and then that votes value. So I won't need to access electoral votes of state. I'm just going to call votes. And so I'll save that and compile and run. And let's look at what gets printed. Nothing here is going to be particularly maybe surprising. We know that those electoral votes have all been updated to 19 for Pennsylvania, 17 for Ohio, and 40 for Texas. But what I would ask you is, what do you think the order here is? One thing that we can see that the order in which the keys and values have been printed, one thing that we know certainly is true, is that they're not getting printed, say, in alphabetical order. MNOP. So Ohio would come before Pennsylvania alphabetically, and then Texas would come. So we're printing Pennsylvania first, so we know that we're not printing the keys alphabetically. You might wonder, well, in what order when we range over this map are they getting actually printed? It looks like maybe it's the order that we put them in. And in this particular case, that's just a coincidence. So in general, when you create a map, or when you range over an arbitrary map in Go, the ranging is going to be functionally random. And you might wonder, why is that? Why would they not give you control over this? And there's a good reason for this. As a brief aside, I'll just tell you, Go didn't want to make a decision about the order of ordering map keys and then change that decision later and then break everybody's code that depended on that previous order. So instead, they say if you want an order, well, you just go in and get that order yourself. And it's an opportunity for us to see that's not actually such a difficult challenge for us to do. As we're getting stronger with programming, that's fine. I can go in and range over a map and get the keys in an order that I want. So let me use this as an opportunity to do so. Rather than have the print statement like this where we're just ranging, and sometimes this is fine. You don't care about the order, but if you do care about the order, then you need to write a function, and let's write that function. So let's have a function called, well, I don't know, print map alphabetical, and it's going to take, let's just make it an arbitrary dictionary, honestly, but it needs to have the appropriate type, so it needs to be a map of strings to unsigned integers, and it's not going to return anything because it's just printing stuff to the console. And in this particular case, what we need to do is we need to somehow sort the keys of the map. And then we'll range over the sorted keys in order to print the keys and values. Okay, so then the question is how to do that. Well, let's create a slice called keys. And that's going to contain the keys of the map. And I'm going to make this be a slice of strings. And we know how long it needs to be. It needs to be the number of elements that are in my dictionary. So that's just the length of the dictionary, which we've seen before. Then we want to do something like for key colon equal to range over the dictionary. And then I want to set keys of I equal to the key. So the first thing I'm going to do is grab the keys, and then I'm going to sort them. So I'm going to have sort the keys down here. I'm just grabbing them first. The problem with this statement, keys of I equal to key, is you can see I has been underlined in red. I does not exist. And that's because there is no such thing as like an I when you're ranging over the dictionary. There's no natural order that's happening there. You say, well, that's frustrating. But again, this is the type of thing as we get comfortable with programming is a very, very simple fix. So if I want an I just make an I. I set I equal to 0, and then it's going to start off at 0, and now every time I go through the dictionary, each new key I encounter, I just need to bump I up by 1 each time. So I'm going to set I++ at the end of the for block. So This will allow me to go in and grab all the keys, and now they're present in a slice. Now that they're present in a slice, I can sort them. And I'm going to use a built-in package called sort to do so. And there is a function in that package called strings that will take a slice of strings, in this case our keys slice, and it's going to sort those strings, and so the ordering of the keys is going to be rearranged for us, which is what we want. I'm going to save that. I've got a Go extension installed, so I'll automatically see that import sort statement appear. If you don't have that, you'll need to type it yourself, but I encourage you to just code in this way. Now that we've sorted the keys, let's range over the keys and print the associated dictionary value. So for example, let's go through I colon equal to, or I should say J colon equal to range over the keys. And here is where I want to get the key, but I'm not interested in the index of this slice. I'm interested in the corresponding value. So I don't care what the actual number is, 0, 1, 2, 3, 4, 5, or 6. I just want all those keys. So in order to do that, I've got this key, and now I've got a string. And now I can go in and get the value associated with key in the dictionary. So I could say the value associated with this key is, and now I could say dict of key. All right, so even though I'm ranging over the slice of keys here, I can access dict of key because I know that that key exists within the dictionary. So ranging over the keys is basically equivalent to ranging over the dictionary. There we go. Let's save that and let's call it and run it. So we've got my print map alphabetical function. Previously, I had the number of electoral votes in the state getting printed out, but they weren't alphabetical. And let me call this instead on electoral votes and save. And I'm going to compile, and I'm going to run. And now I'll see the O occurring before the P occurring before the T, and so everything got printed in the order that I wanted, which was alphabetical. That's it for an introduction to maps. The next thing that we want to do is use what we have learned and return to the ongoing narratives of our chapter and apply maps within the context of analyzing bacterial genomes. So that's what we're going to do in the next code along, and I really hope you'll join me there. And I'll see you then. But until next time, happy coding.